Hi guys, welcome back to Business Stats. This is going to be the first video of Module 6 and 7, point estimators, sampling distributions, and interval estimators. Right off the bat, I'd like to kind of apologize. My voice is a little bit raspy. I'm hopefully getting over a cold or in the throes of it. I don't really know. But have a cold, so my voice is going to be a little bit raspy. But hopefully that's all right. So we're going to just do this how we always do. We have a companion worksheet, so that is available on Brightspace. So go download that or print that off, whatever you need to do to follow along. And we're just going to handle it like that. So just print your worksheet off and then fill in as needed as we go along, okay? Also, by the way, I really love feedback on this concept toward the end of the semester, and I'll make a formal announcement of that. Like, I want to just know if you guys are watching the videos. I mean, I can tell given some of the statistics. Like, I can look on YouTube and see some of the statistics. I can look on Brightspace. They have different statistics that I can see. So I can see in general how many people are watching it. But what I can't see is kind of how you guys feel about the videos and like if they're helpful or not and whatnot. So I'll formally ask for that because I know not everybody watches the videos and not everybody will watch this video sort of thing. So I'll formally ask for feedback on this kind of stuff later on in the semester. But just be thinking about that. Things I could do better, things you really like about it. You know, just in general feedback. So I'd love to hear from you guys, good and bad. So, all right, well, let's go ahead and get started. This is going to be a very short video. But yeah, 6.1 point estimators and sampling distributions. A sampling distribution is a statistic. A statistic is a probability distribution for all of the possible values of a sample statistic that can be derived from samples of a given size. So this is in the slides. So I just pulled that definition right off the slide, and that's how I'm going to kind of handle this. I'll also just kind of tell you my layman's term definition. It's just a probability distribution of samples of a given size n. Okay. A point estimator is a statistic computed from a sample that is designed to estimate a population parameter. So it's basically a stat that we compute from a sample. Okay, so presumably that sample is from some population somewhere, right? So we take a sample of a population, we compute, like we literally run a statistic on that sample, which is something we've been doing all semester, right? We get a small amount of data, we run statistics. Before we called that a descriptive statistic. You know, we take X bar, you know, we take the sample mean. This point estimator is saying, well, when we take that sample mean, this is then an estimation for the population mean, right? Which just makes sense. You take polling in election season, right? So it's a sample of maybe 100 people or 200 people. Hey, which way are you going to vote? Republican, Democrat, you know, whatever. Which candidate you're going to vote for. Okay, so what's going on is they're taking a sample, and that percentage of people voting for whoever is an estimate of the population parameter of, hey, what is the whole population going to do? So that sample, that X bar, that mean, is a estimate for what we think the whole population is going to be. Okay. All right, so then the last one is standard error. Tell us how, and this tells us how the estimator will vary from sample to sample. And then I just gave the definition or the formula for standard error, and that's just sigma sub x bar, meaning the standard deviation of the sample mean. So sigma of the sample mean distribution is just equal to sigma divided by the square root of n. Okay, and for example, it's fairly simple. Okay, an automatic machine in a manufacturing process is operating properly if the lengths of an important subcomponent are normally distributed with mean 117 and standard deviation 5.2. If a random sample of 25 components is selected, what is the standard error of the sample mean. So standard error again is sigma sub x bar. So what we're going to do, I'm going to go ahead and just, as always, let's write out that which we know. Okay? So what we know is we know what mu is. Mu is equal to 117. And we know what sigma is. 5.2. And we know what n is, our sample size. And I apologize if you can hear my kids screaming in the background or yelling. I don't actually know if this microphone picks that up, but my son just ran by the door and was just like yelling. But anyways, yeah. So this is what you get when you record a lot of your videos at home. All right, so we're just going to go ahead and do this formula. So sigma sub x bar is equal to sigma over the square root of n. And sigma is 5.2 from the problem. And square root of n is square root of 25, which is 5.2 divided by 5, which is 1.04. We don't need mu to compute this. But as is customary with whatever problem I'm doing, I'm always going to write down first the information that we have, just so that everything is on the table. Okay, so that's that for 6.1, point estimators and sampling distributions. Come back for 6.2.